This is our list of reduction potentials. Remember, there's oxidation potential and then there's reduction potential. It turns out that there's only one table, though. And it turns out, I'm going to show it to you. This will switch sources for me. Okay, there it is. Here's our table. And the heading of this page 825 in the book. Standard reduction potentials at 25 degrees. Now, the word standard, you remember, we've talked about the word standard before. When we did thermochemistry and thermodynamics, there was standard delta G and non-standard delta G. Gas laws have standard conditions, standard temperature and pressure, that kind of thing. So standard temperature for electrochemistry is just like thermodynamics at 25 degrees. In fact, if I can zoom in on it, you can see that there's a bunch of half reactions, and each half reaction is given a voltage. And that's what I was talking about. The book uses that scripted E, that's its reduction potential. And then that's measured in volts. And this is given, you can see the reduction potentials, I'm just kind of moving down. It goes in order of reduction potential. The highest one is the highest reduction potential, down to the lowest one. And then there's a second column, if I just go over to this column. And then what we see, I can zoom out a little bit, our hydrogen, our standard reduction is right there, I'm pointing at it. 2H pluses plus 2 electrons yields H2. That has 0 reduction potential. So the things that are above hydrogen in the entire first column, those are all better at reducing than hydrogen is. And everything below hydrogen, all these metals, are worse at reducing, which means they do not want to gain electrons. They have a negative reduction potential. Now there is no oxidation potential table, because you can just take any reduction and turn it around. Notice that these are all reductions because they all have electrons in the reactant side. Every single one of these has electrons in the reactant. That's what reduction is, the gain of electrons. If you need an oxidation, you just turn that half reaction around. Then it's giving off electrons. And when you turn the reaction around for an oxidation, you just change the sign on the reduction, and that makes it oxidation. That's what I was saying in that last bullet point. If you read that last bullet, you're like, I don't really know what that means. Flip the sign. Well, that's all I'm saying. So that's what we do with this table. We'll have lots of exercises with this thing coming up with the cell potential. You're going to have to add the reduction potential for the reduction half, the oxidation potential for the oxidation half, add those two together, and that will give you the cell potential. Now, when you make a battery for the battery lab on March 19th, you want the highest possible voltage. The best thing at reducing in the whole world is fluorine. Fluorine's got the highest reduction potential of anything in the universe that we know. The worst thing at reducing would be the last thing, which would be lithium. So lithium, if I move over here, lithium has a reduction potential of negative 3.05. So if lithium is terrible at reducing, what does that mean about lithium? It's good at oxidizing. Lithium metal would be good at oxidizing. We turn this thing around, then we'll have an oxidation potential of positive 3.05. And where have you heard of lithium before? Lithium-ion batteries. Right. They take advantage of the fact that lithium is good at oxidizing. They put it into batteries. Yeah. So, yeah, and when we make batteries, lithium, by the way, is banned. We don't allow any group 1 metals. They're too dangerous. I have a funny story about lithium that I'll tell you later. But, yeah, I'll always remember. Okay, so we'll work on this later, starting. And here's some good news. When you're reading for the reading quiz on Sunday night at about 11 o'clock, a reading quiz, or 4th hour on Monday, right? When you start reading through that, you're going to be like, oh, we have already talked about that. A lot of what we're going to have on a reading quiz will be from this lesson. It just overlaps. All right, so anyway, enjoy that.